Okay, hello guys. So this is the extension study about the probability. So in today's purpose, we're going to talk about the compound probability. Now the word compound may be a little bit unfamiliar to many of you. So basically compound, or we can say compound event in math, we're talking about the probability of two or more events that happening at the same time. So in chemistry, you may know that compound means two or more substance merged together, and in math it's the same idea. When we have two or more events happening at the same time, we call that a compound event. So for example, if we roll dice, okay, what is the probability that the first die is an even number and the second one is an odd number? Now notice here we have two conditions, okay, we have two conditions, so that means two separate events. The first event says the first die is an even number, and the second event says the second die is an odd number. So they are two separate events, and then we can sort of calculate the probability based on these two events. Okay, so when we do that, we can draw a tree diagram. When we draw the tree diagram, let's just think about it. If we roll a die, okay, if we just roll a die, then we'll have 1, 2, 3, 4, 5, and 6. Yes, it's possible to draw, let's just say that 1 to 6 all on the tree diagram, but it's going to make our life a lot messy. We can actually just think about, because the question only focuses on the even number or the odd number, so we can just think about it. There are three even numbers in the die. So 1, 2, sorry, wrong one, my bad. So 1, 2, 3 even number, 2, 4, and 6. So that's the even. Now, so therefore there's 3 out of 6. The probability of that is going to be just equal to 3 out of 6. Now, at the same time, we have the odd number, which is 1, 3, and 5. So we can pretty much say the probability of the odd number is going to be the same. It's going to be 3 over 6, which is going to be equal a half and a half. Okay, so when we draw the tree diagram, we just need to say we roll two dice. Okay, so that's die number 1, that's die number 2. So the first die was split into two chains. The first possibility is we get an odd number, and the second probability is we get an even number. Okay, and the second die, if we just talk about it, it will be odd and okay, so same here, odd and even. Now, because we know each line will stand for this half, so which is like half chance or 50-50 chance. So we can put in the halves all there. So the chance that the first die is an even number and the second one is an odd number, so which means this particular branch. So the probability of that is going to be equal to a half times a half, which is going to be equal to a quarter, or let's say 25%. Okay, now if we just look at another example, now this is one of the easy examples to help you to start thinking about the tree diagram. The second example is going to be a little bit more difficult. So if we flip a coin 3 times, okay, so we know that a coin will come with the outcome with either head or tail, okay, and the probability for each of them is going to be precisely a half, so equal chance. Now, what is the chance that we get at least two heads? Now, the keyword here is at least. Now, when we say at least two heads, that means two or potentially three. Okay, so when we draw the tree diagram, so we can have coin 1, coin 2, and coin 3. And when we draw that, we can split it up to head and tail. The second coin will go to head and tail. The last coin will also go to head and tail, and then to the final point, that's another head and tail, that's another head and tail, and then if we keep going, head and tail, and head and tail. So that is going to be the entire big tree diagram. Now the tricky bit is we need to figure out the probability that had at least two heads. So if we have head, 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 that's the first one. Let's just head, head, head. We write the outcome here. Okay, so we can have the second one, head, head, tail, head, tail, head, and head, tail, tail, head, head, and we can have tail, head, tail, and then we have tail, tail, head, and tail, tail, and tail. So we can circle all the things that fulfills the condition. So when we say at least two heads, then that means we can have three of them. That's it. And we can have two of them, two each, and this one has two head, and this one also has two head, and that's pretty much like 1, 2, 3, 4 outcomes. Okay, so think about it. We have 1, 2, 3, 4, 5, 6, 7, 8 outcomes, and four of them actually has at least two heads. So the probability, to our surprise, is actually going to equal to 4 out of 8, which is going to be equal to a half. Okay, this is a little bit counterintuitive. So that means the chance of getting at least two heads out of three throw is actually a half. Okay, so this is a really typical example. So if you're not sure, you can go through the tree diagram yourself and try to think about this question. Okay, so we're going to push this a little bit further. Now, the last thing we talk about is more of a real life and complex issue. So let's think about a typical game called Blackjack. If you haven't played that game before, a quick sum up of the rule, okay? So the most important rule is it's a card game, and the aim is to get as high as possible, but not get over 21. So each card has a value, so from 1 to 10, and all face cards are considered to be 10. So if you have a Jack, Queen, or King, that's considered to be 10. And the ace, that is ace, can be 1 or 11, so that's a bit of wild card. So for example, if you get an ace and you got a 10, then you basically got the highest possible, which is 21. Okay, so this is called a blackjack. So if you got an ace and a 10, then you can get the straight win. Now, you get two at the beginning of the game. So for example, you get like 3 and you get 5. So that's a random draw, okay? Now you can choose to hit, which hit means take more cards. So for example, you take another 8, or you can just stand and you say at this point, if I add them up, we got like 3 plus 5 plus 8, we got 16 already. That's pretty close to 21. That's pretty risky. So I'll just say no more card, and that's called to stand. That means do not take any more cards. Well, your opponent will do the same job. So for example, your opponent got a 4, got a 6, so he got 10 to start with. He can hit another card. So for example, he take another card which says 9. Now at this point he says, all right, we got 19 already, so he's not going to take another card. Now if you check his score, he got 19, and your score you got 16. So 19 is higher, so that means this will win the game. Okay, so I hope this makes a little bit sense when we're talking about the rule of the blackjack. If you're not sure, just go to any online version. After a couple of rounds, you will be pretty, familiar with how it works. Now, of course, we're just not talking about the game itself. We're talking about the strategies in this game. So we're talking about if we have a particular card on hand, what is going to be the best move? So if, for example, we have a 4 and a 10, what is going to be the best move? Okay, so we are just going to think about this. We got 4 and 10, that means we got 16 already. Sorry, 14 already. Okay, so the next card, we can split into two different situations. If it is greater than 7, then basically that's busted. So that means you lose the game straight. So that's an absolutely no-no. And if the card is smaller than 7, that means you can hit more card. So we're just talking about this particular situation. Okay, so if we get a card greater than 7, that's a bad option. If we get a card smaller than 7, that's a good option. So out of the entire card deck, let's just think about it from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and jack and king. Okay, we can sort of say 7 is good, and anything below 7 is good. So we can have 1, 2, 3, 4, 5, 6, 7 options that are below 7. And then we have the other 1, 2, 3, 4, 5, 6 options that is above 7. So we want this card, we don't want this card. So we can pretty much say that the probability of getting a greater than 7 is, well, there are 13 cards in total and 6 out of 13. And getting a card that is smaller than 7 will be 7 divided by 13. So if we think about the probability of getting a good situation is bigger than the probability of getting a bad situation. So that means at this stage, it will be a good idea to pick another card because 14 is still small. There's a chance that we get another card and then we can sort of get to a higher total without busting it. Okay. Now, of course, when it comes to the gaming strategy, it can be a lot more complicated because it also depends on what cards your opponents get. But we just say from a very intuitive point of view, if we're just thinking about the cards we have, then we can say when we have 14 on our hand, it's good to call a hit than a stand. Okay? Now, you can try to work this out yourself. You can also think about other scenarios. For example, if you get like 15, what do you do? If you got like 16, what do you do? Also, it depends on what your opponent gets, of course. So remember the idea is we're trying to estimate, trying to think about the probability of this game. Okay, key lesson from today, I'm not teaching you how to do gambling. So if you act without really understanding what's the probability involved, it's just based on the sort of like a sense. You sort of think, maybe that's a good idea. So that's called gambling, and many people do that. And that's where you all know that gambling is not good. But if you fully understand the probability of the event, if you are really aware of every single detail, every single information, and in the financial life, this is actually called investing. Investing means you put the money in with the expectation of get some sort of money back. So there's a whole lot of difference. But anyways, after you've done the probability, after you sort of figure out this, and you could have a little bit fun. There's a link on the PowerPoint, and you can click on that and try a few rounds yourself to see if your strategy actually works. Okay, so have fun and thank you for watching. It's good to uh, talk to you. Okay, if you have any questions, just let me know. All right.